Hello. Well, in the last episode we installed this ROM into our computer, and we can now give it some instructions. However, currently the ROM doesn't have any instructions on it, so we need to put some on it, and we're going to do it with the help of this rather interesting Chinese device, which is called a T48 Pro. You can buy them from eBay, you can buy them from Amazon and so on, and they are a sort of device which you can put this chip into, like that. You can lock it down, and then we can go to a computer. Now, the device comes with, let's go to my computer now, the device comes with a extremely dodgy looking piece of software called JECS-1. And what it will do is, if you have a look down here, we can put any number we like in any position on the ROM. I've set the chip to the correct side of ROM, correct size of ROM, type of ROM, and what I'm going to do is I'm going to read the device I've got. So let's read it. Okay, and we can see that this particular ROM is absolutely full of zeros. Now, if you remember, right back a couple of episodes ago, we said that the first thing that the processor does is look at FFFC and FFFD to see where it should go to start running software. Now, bearing in mind, again, from the last video, we're not going to FFFC, we're going to 7FFC, because we're going halfway. I'm sorry, this particular ROM is in the top half of memory, so the ROM's address is the computer's address minus 8 from the most significant bit. So if down here we can see 7FF0, 7FF1, 7FF2, 3, 4, 5, 6, 7, 8, 9, A, B and C. So here is 7FFC and here is 7FFD. Now, due to a quirk in the way that this processor works, it reads the small half of the address first, followed by the big half of the address. So I've got to decide where I would like to point my program to start. I'm going to point it to the address 8000 as far as the processor is concerned, which is going to be 0000 on this ROM. In other words, the very beginning. But instead of pointing it to 80000, I'm going to have to do 0080. It does the small half first. So down here you can see I've got 0080, which will point it to the very beginning of the ROM. It's going to point it to here. And just for the moment, we know the code EA, which means do nothing. Okay, we'll do that a few times. And then I'm going to do a stop code. I'm just going to have to look that up. So let's have a look and see. Okay, so let's go back to JECS-1 Pro, and we're going to go, we've gone EA, and it was DC. Okay, now we have ourselves a program, not a very interesting one, but we do. So it's time to write it to the ROM chip. So let's do that. Off it goes. It should beep once it's done. Perfect. And that ROM chip is now programmed, and we can plug it into the computer and see what it's going to do. So let's do that. Okay, we have got the ROM back in the machine. We have got the Arduino connected to the computer. If I plug in the machine, get power to it, and then I'll clear the serial monitor, reset the computer, and we will have a look. So we should see some setup cycles. 1, 2, 3, 4, 5, 6, and then on the 7th one you can see that it is looking in FFFC for the small end of where it should go, which is 00. Do another clock cycle and it's looks in FFFD and it finds 8 zeros, so it should now go to the address 8000, where it should find some do nothing instructions. There you go, it goes to 8000 and it finds an EA, and then taking 2 clock cycles per instruction, it does nothing for quite some time. And then with a bit of luck it should find a halt instruction at some point. And then it's just doing nothing. Everything has frozen. Okay, and that will halt until the computer resets. Well, that's it. We've managed to program a ROM and get the computer to do a thing. Not a very interesting thing, but let's fix that now. Okay, so in order to write our first actual program, we are going to have to understand just enough about how the processor works. So let's go back to our data sheet, and there's a boat going by. Don't know if you can hear that in the background. And we are going to have a look at one aspect of the way that the 6502 works, and that is registers. Now, registers is just simply a way of saying the processor can remember some numbers. Okay, each register is just one 8-bit number, so 8 individual bits that it can remember and refer to in the future. Okay, 8 bits of memory, very fast memory inside the processor. There are various different registers in the processor. We're going to have a look at, well, 6 of them to begin with, and the bottom 3 of these registers are things that the processor can do by itself. They're under the control of the processor, and generally we're not telling it directly what to do with that, mostly. So, for example, this one is the program counter register. It needs to look at address 1, then 2, then 3, then 4, then 5, and to do that you've got to keep count. The program counter register just keeps count. Done. The stack pointer register we are going to cover in another episode, so we'll leave that alone for the moment. And then the processor status register is all the little bits and bobs of information that it needs to know, one bit of information at a time. Let me give you one example. Here we've got the carry flag. If you remember doing adding up when you were a child and you added up 2 single-digit numbers that ended up being bigger than 10, like 8 and 5, then you'd have to carry the 10, wouldn't you? The processor, if it adds up 2 8-bit numbers that end up being bigger than 255, it has to carry the 255. And so you've just got 1 bit here, which is 1 if we're going to carry, and 0 if we're not. Okay, don't need to worry too hard about this, because what we're interested in for our programming are these 3 registers up here, and these are registers that we can put numbers in and then use them. Okay, there's 3 registers we can do that with. There's A, Y, and X. They've basically all got special powers, and we're going to have a look at one of the special powers of one of them. We're going to have a look at the A register, also called the accumulator, and its special power is it can do adding up. Wow. So let's go down and have a look at some of our instructions. Now, we understand 2 instructions so far. We've got no up, which is do nothing. Here we are. And we've got stop, which is stop. So we've already had a look at no op, which is down here, no operation, and we've had a look at stop, which is here. And by the way, the little black dot means that it's a new instruction for the 6502 we're using here. It wasn't on the original one, but there you go. And it may look, oh my goodness, we've got 70 different instructions to learn, but actually loads and loads and loads of them are kind of the same instruction. Let's have a look down here. We've got load A, and what that means is go to a memory address, find a number there, and stick it in the A register. And of course, load X and load Y do the same thing for X and Y. So those 3 instructions are kind of the same thing. If we have a look here, increment means take whatever number is in the A register and add 1. Or we've got increment X and increment Y, which is do the same thing to the X and Y. We've got decrement, which is make it 1 less. Okay, again, 3 instructions for 1 actual thing. Okay, so if you have a look down this, and I'd encourage you to go and have a look at these instructions, loads and loads and loads of them are pretty straightforward. However, we are going to look at 3 instructions only for our program. Okay, so we are going to look at, let's go back to my notebook, we're going to look at load A, and that needs to come with an address. So 4 numbers for the address, and that means load number at address XXXX into the A register. Okay, the next instruction we're going to look at is called ADC. No, it's not. Yes, it is. ADC, my apologies. ADC. Okay, and then again that has to have an address. Okay, and that means add with carry. So in other words, it's going to add things together, and if it goes above 255, it'll flip the carry flag, which is the thing we were just talking about. And that's, so add number at address XXXX to A. Okay, and then the final thing, instruction we're going to have a look at today is CLC, which doesn't have a memory address because all that does is clear the carry flag. Okay, with that in mind, we can now write our program. So if we want to add 2 numbers together, the first thing we need to do is to clear the carry bit, as we said. The second thing we need to do is to load a number into the accumulator, and we've got to have a look at an address to load it from. Don't forget the ROM is in the second half of memory, so it's got to be a number bigger than 8,000. We want it to be sufficiently higher than 8,000 that it's not going to get in the way of the program we're trying to program, so let's make it 9,000. Okay, we'll have a look at 9,000 for the number to load into the accumulator. We then have ADC, which means add with carry, and we'll have a look at the second number, which we'll have a look at 9,001 for the sake of argument. Okay, and then finally, and I'm not sure if I said this instruction, but store A. What that does is it spits out the result of our calculations to an address. Now, the problem is we don't have anywhere to spit it out to. Our current memory is read only. We can't write it out to that ROM. So we're just going to have to spit it out to an address that we haven't connected up to anything, and then we'll remedy that in a later program. So let's store that. I don't know, where would you like to store it? Somewhere less than 8,000. Let's store it at 4,026. Why not? Okay, that could go anywhere. It's not going to do anything, so I just thought I'd make an interesting number. Now, in order to actually code this onto the ROM, we're going to have to work out what the opcodes actually are. Don't forget, we can't put in STA and CLC into a ROM, we have to put in numbers. So, if we go back to our datasheet, here is our opcode matrix, and we have to find the right opcodes, and for reasons which I'll explain later, we're looking for the opcode with a little a underneath it. So, for example, here we go, I found it here. LDA here is opcode AD. Okay, so that's what we're going to program into the ROM. CLC, there's only one CLC on here, and that is opcode 18. Okay, ADC is opcode 6D. And then finally, store A, which is the one that's going to shout it out, is opcode 8D. Okay, let's get rid of the datasheet for the moment, and we are now ready to write our program. Okay, so our program is going to go like this. Clear. Then the next thing is going to be AD, and then I need my address. Now, if you remember, we have to put the address in backwards. It's called little endian format. So we put the little half first. So that goes 0090. Then I have to ADC, so that's 6D. Little endian format again, 0190. And then I have to store A, 8D. And again, little endian format, 2640. And that is our program. So let's get that onto the ROM. Okay, let's go. ROM chip goes into the programmer, like so. Lock it in. Let's go to our screen, and we are going to read in the ROM that we currently have. And if you have a look now, do you remember we've got right at the bottom, we're going to tell it, oh, there we go, right at the bottom we're going to tell it to go to the beginning. That's our reset vector. So we can just put our program in at the top, and then we will be fine. So let's start at the beginning. And our program is 18 to clear the carry flag, AD 0090, 6D 0190, 8D 2640. Okay, and that's our program done. Now, the other thing we've got to do is, of course, we've got to put in the data. We said we were going to put it in 9000 and 9001, which on our ROM is 1000 and 1001. So let's go and find ROM space 1000, which is here. Here's 1000, and we want to add, put a number in. Now, okay, we've got to choose two numbers to add together. And there we go. There we are. We have programmed our program. Let's write it to the ROM. And then we can plug it into the computer and see if it does what we think it will. Okay, let's go. Okay, the ROM chip is in. The Arduino is running. Let's have a look and see what happens when we run through our clock. So the first thing we do, as we get some clock cycles, just do the reset, and then we go and look for our reset vector. There we go, we're going to 8000, and when we go there we find the command 18, which is clear the carry flag. Then at address 8001 we find the command AD, which is load A from address 9000. So load A, and that takes 2 clock cycles, and then look, here is our address 9000, which is in little endian format, so that's 0090. So then it goes to address 9000, and what does it find there? It finds our hex number 71. Okay, then it jumps back to 8004 and it sees the command 6D, which is add with carry flag. Takes 2, that only takes 1 cycle. Okay, and then have a look at this. It's looking for address 0190, so that's 9001, and it goes there. And look at that, it finds the value 4C. And what does it do to that? Well, it adds it to the A register, and then we get our next command, which is 8D, which is store the results out on 4026. There we go, can you see we've got 4026 if you read it backwards. And then finally, now have a look here. Okay, it's writing. This has all been reading. We're suddenly going to write out to address 4026, which admittedly is connected to nothing, and it's writing out the number BD. So the question is hex 71 plus hex 4C, is that in fact BD? Well, 1 plus C is D, and 7 plus 4 is indeed B. So we've got the right answer. Hooray! Okay, now that's all very good fun, but we of course can only see the workings of this computer by plugging it into an Arduino, and real computers have some form of output. So in the next episode we're going to consider how we could get the computer, rather than just screaming into address 4026 into the void, we're going to have a look to see if we can get it to do something with some sort of output. Until then, I will see you guys next time. Thank you very much, and goodbye.